Hi, my name is Morgan Ekbefjord and I am the CTO at Scaleout. One of the exciting projects we are working on is the open source federated learning project FEDn. In this video I will show you a small scalability demo of FEDn where we will run a hierarchical federated averaging on 100 nodes spread across Europe. This demo runs on real separated hardware and it will address the three main challenges in federated learning: data heterogeneity, system heterogeneity, and scalability. FEDn consists of a scalable and flexible architecture with three main components. We have the reducer, the combiner, and the clients. Clients work on local data, and no data is ever sent across nodes. The model's averaged weights in this scenario will be averaged on the combiner level and aggregated across, and on the reducer level and aggregated, and new global models will be decided on by the reducer, who then relays those models out to combiners and back to clients. In this example I'm using image data and a neural network together with the hierarchical federated averaging algorithm. So let's start by starting up the reducer. Reducer will then give us access to the FEDn interface, where we have control possibilities to control the federation, history to look at models, and this is our initial model. The initial model resides in this case, a configured to fetch it from S3. And we have dashboards to visualize different progressions done by the algorithm. With the reducer started, we can attach a few combiners, and to the combiners we will address a couple of clients, 45 on this node, 40 on this node, to show you even the system heterogeneity, and we will have 16 booting up from this node. Now the alliance is ready to train. Let's do an initial round just to see what's happening. The command to train is relayed through the reducer to the combiners, and the combiners relay and control clients to train. When training is completed, the results is aggregated back to the combiners, and the combiners then average those models that has been received and sent them up to reducer. When there is a new global model, those are sent out again, a new request to validate that new model on the local and separated data that each client has access to. When the model validation result is back, the validation result is sent back to the reducer. Reducer then takes a decision if the model has been progressed good enough to be part of the alliance. In this case, we have a new model and the step is complete. To show some good progression, we run a couple of more rounds. So now we have seen our progression running on 100 different nodes. Our model has progressed from 0.55 to 0.72 in accuracy, and if we look at the timeline, we can see how the different training and validation requests have been completed in different time slots and in different rounds. And as you see here, the training is done synchronously and validation is run asynchronously. We can see the round trip time has increased across workloads, which likely depends on that the system is being loaded more and more. Here you can see the CPU and memory allocation across rounds, and you see at the end of each round there is a spike in CPU utilization because of the averaging taking place at the combiners and reducer. Still working to validate the final round, and now results are starting to trickle in. And that's the conclusion of 6 rounds we have started. First was a single round and then 5 consecutive rounds. We can see in the timeline how those rounds have been progressing. Validation workloads are still executing. When additional results come in from different nodes, you can see that for some nodes it will be very bad, but the average would be good, and the model progressing in that direction that it suffices node requirements. Okay, completed 6 rounds now. We can see that the model has progressed with a slight deviation on the last round, but it's very applicable that it could find the local maxima before continuing. So let's close down our 100 nodes, and we can conclude this demo by showing how we have trained on 100 different nodes. We can show that we can handle the data heterogeneity. We can show the system heterogeneity by loading those different hardwares with different number of clients, in this case, for this demo. And we have shown that we have handled this scalability issue by issuing 100 clients. Thank you. If you want to reach us, contact us at scaleoutsystems.com and visit the FEDn pages for more information. Thank you.